Hello, everybody. Welcome to this session on extending Teams message extensions into Copilot from Microsoft 365. This is part of an awesome program from the Copilot Connection team, Month of Copilots. I am your speaker today, Paul Bullock. I'm a Microsoft MVP for about 4 years now, covering two categories, Microsoft 365 development and apps and services. I've been working at Avanade for the last 2 years, and as a modern workplace architect, doing various projects for large enterprises. I've been in the industry for about 18 years now, with SharePoint on premises and 12 years online, as well as the Microsoft Stack and Azure. Generally, I'm an all-round geek with the latest studies in AI and Copilot technology, which leads me very nicely into this talk. The first part, what I wanted to cover as part of this talk, is the types of extensibility you can do with Copilot. So there are four main types of extensibility options to you. So for example, connectors, message plugins, Copilot Studio plugins, and newly announced API plugins. They're not quite released yet, but this is another option that you can to extend Copilot. So let's just run through this very quickly. So connectors allows you to connect a variety of data sources to bring your own data into your application, into Copilot. This could be from a database or an external system where it is indexed in the search system, and then you can query against the information in search. Because it's in search, it's also part of the semantic index. And then, of course, Copilot can then use that information to query that data source when you prompt for that information, which is super, super cool. So the next one we've got is, and this is the focus of the talk, are message extension plugins. So this is done with the bot framework and a combination of Teams Toolkit that provides you this sort of framework for an application within Teams. You can then configure this in a way that will surface in Copilot to produce that response to your to the user's prompt based on, say, information from an API or some other sort of data source. So it's pretty flexible what you can do with this in a sort of pro-code manner. And moving on to Copilot Studio plugins. So this is more of the Power Platform-based solutions where you can use that sort of nice user experience to generate your sort of Copilot plugin with a variety of options. It's not something that I'm focusing on in this talk, but I recommend that you go and check this out as another flavor of a way you can extend Copilot. And then finally, we've got API plugins where you can essentially map a plugin against an API that conforms to the Open API specification and automatically generate out an application that will plug into Copilot. This is very, very new, and I won't go into too much detail about it because it's not yet released for us to play with in the industry. But again, this is another type of way you can extend Copilot, which is super, super cool. I do, however, recommend checking out BRK 150 from Build 2024 session where Jeremy Thake, Baron and Bora did an amazing job and a talk around the whole Copilot extensibility story in much, much greater detail. I highly recommend checking this out to get that sort of overview and that picture of the whole extensibility story. So you might have heard me mention Teams Toolkit. So let's dive into a bit more detail about what that is. So Teams Toolkit is an extension for either Visual Studio Code, the free version editor, or Visual Studio, the enterprise product, where you can scaffold out your Teams application very, very quickly from a set of defined options. You get to select what kind of app you are after. So this means everything you need is in place for you to create your Teams application. It comes with a set of default Azure artifacts, such as Entra ID apps and resources, where you can deploy this very, very quickly without having to do any sort of initial legwork to get an operational application into Teams. So it provides that sort of framework all in place for you without you writing a line of code. It also provides you the ability to publish to the application to your organizational stores or app source if you want to create this into a commercial product, which is super, super powerful. It also comes with a variety of tools to build up different types of Teams applications. such as tabs, message extensions, and so forth, to help you build that application very quickly of the type that you want for your business scenario. It'll also help you debug your applications to find those faults and quickly correct them, and also to get running very, very quickly with a very simple F5 run experience to get yourself going. So imagine now you've created a Teams Toolkit based projects or a message extension for Copilot. You may already have an existing one, and that's okay, but what would it take you to transform the message extension to something that Copilot can understand and surface results from the user's prompt? There's a few things you would need to incorporate into your app to get Copilot to be responsive. Firstly, the type of Teams application must be a search-based message extension, as this is the only currently supported method of extending Copilot that can you use. And you can use Teams Toolkit to generate out the scaffold of this project for you without you having to do any initial development work, including the Azure resources to support running this application to get you going. And with a nice example that allows you to get running with the F5 experience. The second thing you need is a tenant with Copilot for Microsoft 365. Currently, at the time of recording this, Microsoft does not provide a developer tenant, a free development tenant, with the Copilot experience. So either you've got to use an enterprise one, so your work may have alternative tenants for development that they can equip with Copilot, or you buy one for yourself with a minimum subscription that allow you to buy then the Copilot add-on together. The next step is to make changes to your manifest. You don't have to do this, however, there are changes that you can make to the manifest to improve the way Copilot responds to your application. We'll talk about that in a bit more detail later, about the areas that you can modify in order to become more responsive with Copilot when a user has issued a prompt, and Copilot then determines whether your application is suitable to satisfy the prompt response. There's also optional architectural changes you may need to consider making to your APIs if you choose that route. If you bring an API in from an external source, you may have to make these tweaks to the API itself if you own that service in order to make sure it responds to a timely fashion, or it can be used to accept a variety of inputs that Copilot will determine based on how you define your command parameters within the Teams manifest. After which, Copilot will then use these command parameters to then call your API. And finally, you need to consider carefully your adaptive card output, as Copilot will use this information to provide the summarization of the information to your users as part of the response to the prompt that you've returned from your application. Using this, you also have the option of building rich adaptive card experiences to provide that pizzazz for your end users. Another cool feature is you can apply actions to it, which allows you to call other functionality within your application or another application external to your Teams application. And there are new capabilities coming in this space later on this year, such as actions, which means Copilot can respond and actually perform some of the actions, or at least determine out how it would then proceed next for you, and you confirm that operation. And handoff, where you can continue the conversation with another application, either that be a custom Copilot or a chat application within Teams. Next, I want to provide an example for you on how you can apply this. So what I've done is I've built a community sample that's now released to demonstrate this in front of you now, and also for you to refer to later on how you can extend a Teams message extension into Copilot. So I've used a scenario here. It's a backend application which calls the Microsoft 365 Service Health Announcement APIs, so you can get all the information about the changes in your tenant or any service incidents. I've used a combination of Azure components. So I've used Azure Functions and Azure Automation with PnP PowerShell, because you can use PowerShell scripts in these services to provide that logic of the application. And then I've used SharePoint to cache the data for quick retrieval. But please note the SharePoint site must be configured with the search disabled on the site so not to interfere with the Copilot results. This then provides a back-end example API for my Teams Message Center application. So what I use the rest of the application for is to provide that front-end experience for either the message extensions in the chat or via Copilot, which can then be presented with a variety of adaptive cards. So when the user prompts for information from the service announcements or the message center can be called through the Copilot, which then can call my application. Then the Azure function retrieve the data from SharePoint and then quickly return the results to the Teams message extension. I purely use Azure Automation to keep the SharePoint list data up to date with fresh information from the message center. And the primary reason for doing this whole caching is because I found that a direct implementation via PnP PowerShell was too slow, causing timeouts within the message center and Copilot itself, which leads to the "I'm sorry" message in Copilot. There's probably other ways that which you can architect this, but for the purposes of the example of this demo, I don't need that at this time. One of the most important factors about integrating with Copilot is your app descriptions. This may sound strange. Getting it right or wrong can greatly influence the results of your Copilot experience when the user makes that prompt. You are potentially competing with other data sources such as M365 data or other Copilot plugins. I've seen Microsoft making improvements in this space, which has been announced to build. But essentially, you need to allow your Copilot to determine if your app will surface the right answer to the user experience. The following main areas you need to consider is the application description. This is not just for the end user, but for the LM as well. You can describe your app in a very clear way. What does it do? What are the benefits? What can it provide you? And the description of some of the examples of its functionality. The next is a command description. So there's a new field in the app manifest version 1.17 upwards called semantic descriptions. This allows you to provide an LLM-like description of what you want the Copilot experience to do. However, some of the construction of these descriptions may seem less user-friendly, so it's a good move from Microsoft to split these out into separate properties in the Teams app manifest. If you do not populate the semantic descriptions, they will default back to the original descriptions property. Lastly, describe your command parameters. What do they do? If it's an ID, for example, perhaps give an example of what that ID format might be if you use an alphanumeric combination. So, for example, in my message center, there is a couple of letters that pronote the product and then a number after the messages as part of the ID. If the user then includes that ID in a prompt, then it will help Copilot to determine that ID format and populate the right command parameter, which is a super cool feature. I've also seen new properties in the app manifest, perhaps supporting a new first run experience, prompt library, or plugin suggestions coming soon, where the app manifest will allow you to provide sample prompts giving guidance to the users when they start your application on what to do next, what kind of things they can ask your application, which I believe will greatly enhance the user experience. This is currently not yet available, but it is suggested that this is coming soon in both the app manifest, the fact that it exists in the app manifest, and the documentation refers to this capability. Let's dive a little deeper into the manifest for these command parameters. The main difference between Teams Message Extension and Copilot are these three main points. Firstly, Copilot supports up to 10 commands with up to 5 parameters in each command, but it is best to have at least 3 command parameters per command. It's also worth noting that if you're calling an external API, you must understand these APIs must support these additional properties and have tolerance of whether these properties are empty or populated by the Copilot orchestrator, as it may choose not to use these based on what the user enters in their prompt. Secondly, keep the properties simple, perhaps specific to their data type, such as a number or ID, single word parameters that you can use in combination with a semantic description to describe what you want Copilot to populate it. So, for example, I have used workload as one of my parameters on my API, which may represent a product within Microsoft 365 as a filter to the results coming back from SharePoint. Finally, beyond the first parameter, these do not pair with the message extension's user experience, which means you need to carefully choose the first parameters to both support the message extension, so that's within the chat experience, or Copilot as their inputs. In this next slide, I'm going to show you an example of how a prompt and intent is mapped to a command property. So what do I mean by this? So if a user makes a prompt, for example, are there any health issues with SharePoint in the message center? Copilot will extract out the keywords to populate the inputs of your command property in your Teams application that will then be used to populate the parameters of your API. Copilot will try to map the intent of the appropriate command property. For example, on screen here, you'll see the first prompt, any health issues with SharePoint in the message center. This will determine the word SharePoint as part of the workload and populate the search workload field, as I've described in the semantic description for that command property. It will also use the word message center as a way to target my application specifically. In the second example on the screen here, the prompt show me SP6755293 in the message center. Copilot can recognize the format of this and populate the search ID. Again, I've described this in my semantic description to provide that example to Copilot. So if the user includes this in their prompt, it can be mapped accordingly. It's also worth noting that if you have to consider your prompts very carefully, as it could be used to populate properties of your API accordingly, together with descriptions in order to make the instructions clear to Copilot. Right, now enough of me waffling on. Let's get and see some demos of this in action. We've now switched over to the demo. So this is the Copilot Message Center Teams application built with Teams Toolkit, scaffolding it out. And this is what a typical structure of a project looks like. So firstly, let's go over to Teams Toolkit. Clicking into there, you'll notice there are several sections. So we've got environment, which controls all the properties of your environment you're connecting to. You've got development guides, the life cycle, whether you're provisioning a new app, deploying or publishing, utilities, and help resources for you to get started and to through that. You've also got the accounts that shows it connected to Copilot within the tenant and 365 tenant, and then you've got Azure resources that you're connected to. So let's switch over to the Teams app manifest. So locate the manifest under app package. Here we're using version 1.17 of the manifest, which show things like the descriptions. You've got semantic descriptions here as well for the commands. So the command is called Search Message Center, and we've highlighted the semantic descriptions there. And we've got the command properties as well, which have also been fully populated with those. This is an example of the semantic description for a command, and then the command parameter itself. As you can see, the difference between the two, one suitable for the end user and one suitable for the LLM. And each of these will be different to give that instructions to the LLM, to provide what to expect. So, for example, a workload or an ID with format suggestions, and then that search type as well. And here are some sample prompts for when that user experience does appear in Copilot in the future. Right, let's now walk you through the project structure. So obviously this is the Teams app manifest, which is located under the app package folder. The other folders you've got here are the documentation, the environment variables. So for example, specifics of your tenant or your environment that you're developing against or publishing against, and also a user sample there for your secrets as well. That's what the .user reference is. You've got the infrastructure folder, which contains all of your Azure-based deployment scripts in Bicep, all those parameters as well. And in this project structure, we've also got things like the source code for the application itself. Under here, you've got adaptive cards. So this is where all the adaptive cards are stored. So this is useful to, if you're developing adaptive cards and you want to preview these, then there is a nice preview built as part of this. So F1, click on that, and then you've got that sort of presentation of what that would look like, which greatly adds to the speed of developing this as well. You can select your theme and so forth. And you can choose between different adaptive cards to see how their output is shown. This then becomes a very useful tool to build out your adaptive card experiences without having to go around the circle deployment to the application and see the results. As you can see here, we've got the positioning, you can see the rich formatting, any sort of buttons and conditions that you put in there, which is super cool with a previewer. So just collapsing that, the next thing we've got is the search application. So just scrolling through the top, obviously you've got your conclusion statements, but the next main bit is when Copilot populates the parameters. So what we can do here is take the parameter inputs and then associate them to fragments for URL generation. We can combine that to URL and then call Axios to get the results from the API. Then we collect who it's from. Then we see what the response is with the messages, and then we cycle through that data and present them in adaptive cards. So there's two adaptive cards, so there's two groups of responses, each for messages and service extensions, and then we return that back to Copilot to present to the end users. Another thing to note as well is we've got a handler here for the follow command. So there's a button in the adaptive card where you can follow the incident that or announcement that's been made. We've got a handler for that under utility. And within this class here, we've got a set of code that then, when called, the follow action then formulates out a new URL, which does some validation. It creates the inputs from the adaptive card, calls Axios again to initiate that following operation, and then obviously we handle any errors that might come back from that service and responses as well, which then gets fed back into Copilot, and the adaptive card is responding accordingly. So the next thing we're going to look at is debugging this application. So here we're going to select the debugging menu to debug in Copilot. This is going to trigger off the build operations, running through a checklist of validations, and checking things like provisioning your bot registrations and so forth. So to ensure that all the components are in place, so when you are debugging, all the updates have been made to these components before Chrome is presented in front of you. So this will happen fairly quickly. As it went through, it's passed all the checks, which is great news. We're just waiting for the last bit where it's deploying the application. And then we can see this starting to load up the Copilot, the Chrome application as well, so we can see Copilot in action. There we go, everything's ready to go. Chrome's starting to load now, and let's bring that over onto the screen. This is loading Teams up now, so you've got that full Teams rich experience. This is not a workbench of some kind. So what I'm doing is positioning the window so that you can see any messages that come back from the bot, as well as Copilot in the presentation in front of you. So just waiting for a moment for that to load a bit further. Yep, almost there. And here we go. This application is now loaded straight into Copilot. As the Copilot user experience is currently loading, and here we go. You can see it's ready. So now that Copilot is fully loaded, first thing we need to do is make sure the plugin is enabled correctly. So we may have two, dev and local. Make sure local selected. to ensure that it's running on your application currently running Visual Studio Code. Now you can begin the prompts. So just trigger off one of the prompts for that to then generate across. So for brevity, we have sped up the video in certain elements of this in order to load the results quicker. As you can see behind the window, Teams is calling the API, and then Copilot is producing responses from that API in a pleasant way. It is reading the results from both service health and service announcements, where we have combined those adaptive cards. And here you also got the developer view as well, so it can show things like the success of that. So here's the response here. You've got it formatted in bullet points, which has come from the endpoint here, and the results is 5 each. And then we've got things like the service announcements as well, because we're calling the endpoint does return both types of data back. So there's 5 of each in those. And then, as you can see here, we've got the preview of the results, the areas where you create it. I've put a little icon to differentiate between the both results, so it's a bit easier to see from the user experience and from a debugging perspective. So if I hover over one of these numbers, you see that rich adaptive card experience with the details of the message that's issued. What we're going to do is later on we're going to grab the ID and also whether I'm following that incident, which is why I grabbed the who as part of that logic. So let's take an example here. And let's grab the ID of the service health incident. So what we're going to do is create a new prompt for that ID. So I'm going to show me the details of this ID in the message center. So I am specifying the application here, just make sure the results are returned accordingly. That is going off and generating that. As you can see behind the scenes, you may notice the API is being called. The parameter is different based on what was selected from the prompt. And it's returned again a bullet point list of information from my adaptive card. So we've got the PowerPoint incident. Of course, this might be happening at the moment, so this was an old incident. You've got the information presented in front of you, and then the adaptive card below you as well. So the status of it and any data. So you have an action to follow the incident if you wish to record and get more information about it purely. You can choose what process you want to, but when you click on that, it calls the API to register that you're interested in following that, and then the adaptive card is updated with a success message to show that you have initiated that follow process. And here is the information from the development mode. So when you enable the development mode, you can see what was searched for, how it matched your application, what plugin was enabled. Then we've got the functions with it. So the search message center function has been detected, and then of course it's selected that function for execution, and then this is the response result. It's got a status of 200, so it's a success. And that's key to understanding whether your application has responded accordingly to the prompt on the screen. So let's do one final example showing the workload. So we're going to call we're going to create another prompt. So show me Copilot in the message center. We're going to call that prompt off. It's going to gather that information. It's going to call my API again and selected the search workload and populated the word Copilot in it. It's found 5 results. It's now presenting those results on screen for you as part of the output from the adaptive card experiences. So while that lists them out, as you can see, there are a few there. This is almost finished generating results. And there we go. There's your list in front of you with all the information. So one thing to note as well, expanding this, is there could be results from other data sources, such as my graph connector from another sample. And that will show up slightly differently as part of the message response because of the information was so close to the response. But as you can see in the adaptive cards, each one has got a nice presentation, the status information that you can quickly view through to get that more information as well. And that concludes the demo section of the presentation. So let's recap what we've seen here. So during the demo, we showed you things like how to lay out the package, what Teams Toolkit is. We've also shown you things like what changes you need to make to your app manifest, and also what potential code you could write for that. There wasn't a significant amount of code in this extension. Of course, this is a demo and your application may be much richer, but it didn't take much code in order to connect and call the backend API and then present those results back. And Teams Toolkit does provide a lot of that framework for you, and it didn't take much to extend into Copilot and show those sort of rich results. But there are three things that you must, if you're going to take things away from this presentation, there are 3 points you must follow. Things like your application must be a search-based message extension, as currently at the time of this recording, that is the only available option to you to extend Copilot with Teams message extensions. It's also important to describe your app very carefully in your descriptions. So I've got a blog post that's coming out later that will describe this in more detail and the effects of what happens if you don't put these descriptions in. And let's just say the outcome is less favorable and less preferable from a results point of view for Copilot. The one thing that kept tripping me up as well during the setup of the sample is watch out for timeouts. The documentation is around 6 seconds for response time. Ideally, keep your response as quickly as possible. It's one of the main reasons why I use SharePoint in order to cache that data, because the response time would drop down from 6 seconds down to 900 milliseconds. So it's super, super fast to get the response back. But that's an example. You could use other caching mechanisms as part of your application. So if you are looking for more information about how to extend Copilot, there are different methods you can do this. You don't have to use Teams message extensions. I have mentioned Microsoft Copilot Studio. So that is the low-code way of extending Copilot. So what I have done here is presented on the screen a few options here from Build that I highly recommend you view in more detail in order to get more information about how you can customize the experiences. So BRK 150, Developer's Guide to Customizing Copilot, gives you that overview for all of the types of Copilot extendability options that you have. And then you've got things like that deep dive on building plugins for Copilot that reach to 320 million users in the field of work with your Copilot with Teams, and then Copilot message extensions with the low-code Copilot Studio. So these recordings will give you a much better insight into the depth and also what's coming up in the future as well as part of these experiences on how you can build these Copilot extensions. So I've compiled a list of useful resources for you. So if you're looking to build your knowledge even further with Teams message extensions or Copilot and the methodologies that you need to do to build these out, or even samples. Samples are useful to get a sense of what options you have when you develop this, and maps you'll draw some inspiration on how they are built as well, as there are very different ways that you can build this. Even with Teams message extensions, you have two options with Node.js or C# based implementations. So either with Visual Studio Code or Visual Studio. So again, these samples would be useful for you to learn how you can do in each. And there's also a set of MS Learn modules, and this is a growing list. It's rapidly being added to all the time. I recommend checking those out to up your training as well on these on this information around Copilot extensions. Thank you very much for attending my session on extending Teams message extensions into Copilot. I hope you've enjoyed the session. Of course, I'm always looking for feedback. If you want to contact me with any information or want to figure out what I've got on my blog, then check out my website, pkbullock.com. And what I've got is a QR code on the screen with all these links so that you can take that away with you and learn that a bit further as well. So thank you very much. And if you've got any questions, by all means, reach out to me or post in the chat. Thank you very much. Have a nice day. Enjoy.